Hi, this is Randy Rice, and I would like to present a short presentation here of how to perform structural white box testing. I posted a podcast episode recently on the need for all of us to start thinking about how we're going to be testing the code that comes out of AI. And this is something that I've been teaching for almost 30 years now. And in fact, it's even longer than that when I think about it. It's probably more like about 38 years. When I created my first unit testing class for the medical lab that I was working at, we were having an extremely high failure rate. 50% of every change had a major defect in it or a series of major defects. We got that down to 2%, which I would have rather had it 0, but from 50% to 2 is pretty good. And this is one of the big ways that we achieved it, was teaching the developers what it really takes to perform good, rigorous white box testing, sometimes called also structural testing. Some people also call it glass box testing. The idea behind this whole realm of testing is that you know what's going on inside the thing that you're testing, whether it be a module, unit, however you want to define that, even a system. So let's get into it. Now, this material comes from one of my other courses called Test Planning and Design, and we have a module in there dedicated to unit testing. I also have a course on unit testing that's in e-learning format, so very obtainable, very easy to do, very easy to get, and I'll share more information about that at the end of this presentation. Anyway, the idea behind structural testing is that it's a very logic-based kind of test, and if you take the little code here that I have on the slide as an example, if the test date equals the current date, move 1 to process code, else move 2 to process code. So you can see there that basically we need 2 test cases to completely cover this decision. We need one where the test date is equal to the current date and one where it isn't. Now, if we compare this to something like black box testing, we would probably test maybe 3 cases in that situation. One where the test date is less than the current date, one where it's equal to, and one where it's greater than, simply because we don't know which logical operator was used. Now, I'm going to point out a flaw in all of structural testing that really requires that you do good functional testing alongside it. So just look at this if statement, and we've already said you move 1 to process code or 2 to process code. Well, how do we know it's a 1 or a 2 that should go in there? Well, the answer to that would be you would look in some kind of specification or a requirement, maybe a user story or something like that, to really understand what should be going on in detail in things like this. Now, one of the gotchas here with structural testing is that your basis of testing, in other words, the thing that you're basing your testing upon, is the code itself. So it's almost like we start out with an assumption that the code is correct, and now we want to test to make sure that the logic does what we've coded it to do. Now, that's a very important type of testing to do, but once again, we need to balance it with functional testing. Now, I also need to draw a distinction here that this is not the same thing as test-driven design. Test-driven design takes a whole different approach. You design your test before you build out the code, and even as you're building out the code. But this kind of takes the approach that the code has already been built, okay, has already been written. So anyway, that's just a real quick example. Now, the process to do structural testing is actually very simple. There's basically 4 steps involved. You identify each decision point. We'll call those our nodes. You draw a structure chart. From that, you build a decision chart. And then for each row of the decision chart, you'll translate those decisions into a test case. Basically, each row will represent either a path through the logic or at least some decision that you want to test. So as an example, let's take this if statement. Actually, it's a little bit complex because it's a nested if statement. And I've tried to use just some pseudocode here. I mean, I know it looks like COBOL if you've ever done COBOL, but it's basically something that I think most of us can easily understand here. So basically what we're saying here is at that first if statement, if the customer is on file, we're going to label this as node A. If that's true, then we ask if the customer code is A and years on file greater than 3, that's node B, then set discount rate equals 0.05 and go to exit. I know go-tos are not to be done, but let's just say that we're going to violate all the rules, and there's going to be an exit down here, okay? Else, we set the discount rate to 0. And then we perform the customer edit routine through customer edit exit until we reach end of customers. And then we go to exit. And now if the customer is not on file, then we hit this else and we go directly to exit. Now, if you're looking at this very carefully, you might see here that I've actually embedded a defect. The period in this example we're going to say is a delimiter. Usually, you'll have some kind of delimiter in the code that you're working with. In this case, the correct delimiter would be this one down here at exit. So we don't really have to spell it out. We could have put a period down here after this exit next to the bottom, and it would have just defaulted down to the next area of the code. However, I think it's good practice to put the else there. It avoids the problems that you have sometimes with an implicit else, where you just kind of assume now we're on the other side of the if statement. So from that, we're going to draw a structure chart. So remember, we had the 4 nodes, A, B, C, and D. And now that B, there were actually 2 conditions with that. Okay, both had to be true to be considered true here. I didn't break it into 2 conditions just to kind of keep things simple, but we could have. So if condition A here, if the customer's on file, then it falls through to condition B or node B. Now, if they're not on file, this is where you just simply go to exit. Now, if B is true, then if B is false, we go through this perform customer count routine, and we stay in that until everything is done. And then once we've reached the file, that's virtually the false condition here. Then we go to D. Also, when B is when B is true, we go to D. Now, if we kind of look at that, if we look at it kind of graphically here, I'm just going to draw for a minute. So we have that way of getting to D. We have this way of getting to D. We have this way of getting to D. And we also have the loop through C to get to D. So if we were to cover all of those paths that I've just shown, we would have achieved full path coverage of that construct. And so next thing we do is we build a decision table. And so here's our A false, and because it's false, we never hit B, so there's not a true false there. We never hit C, no true false there. And D is not really a true false construct anyway. It's just basically an arrival point. So I've got dashes there. Now, on the second row here, we have if A is true and B is true, then we go directly to D. And if A is true, B is false, then we get to go down to the customer count routine. And the first time we're in there is going to be true. And then when it's done, we go to D. Or actually, we don't actually go to D when this is true. But when we go down to the next column, when A is true, B is false, and C is false, then we also arrive down there at D. So the last step then is you put this in some kind of human readable format. So like test case 1 is the customer's not on file. Test case 2 is they're on file, but they're code A and they've been on file greater than 3 years. Test case 3 is the customer's on file. The code is not equal to A, or the years on file is less than or equal to 3, and the end of the file has not been reached yet. And test case 4 is the customer's on file. The code is not A, or they've not been on file 3 years yet, and then they've reached the end of the customer count routine, file. So those would be the 4 test cases that would take you through that code every way that you can go through it. Now, just a word about control flow charts. I'm going to show you some examples of some of them that you'll typically see if you draw these out. Now, a lot of times people don't draw them out, and that's fine. You don't have to. But some of the static analysis tools out there will draw them for you, and they are helpful sometimes in understanding code. So when I'm just going from one node to the next, this was a simple sequence where we just had the 2 bubbles here. This is an if, then, else construct where if is true, we go to that side of the graph, and if false, then we go down through that side, let's say. And then we have the do while construct. So we stay in this loop while something is true. When it becomes untrue or false, then we go down to the end. Same thing with until, except a minor difference here. We're not interrogating it just at the top, but we're also interrogating it at the bottom. So at any point in this loop, then we can bump out and we can go to the exit point. There's also the case construct, where let's say maybe this one was F1, this one was F2, this one was F3. Then as we go through here, then for each condition or each function or whatever the case may be, pardon the pun, we would take that option in going through the control flow chart. Now, it's important to understand that these levels of coverage build on each other. So at the lowest level of coverage is statement coverage, where we're just saying we've covered each line of code at least one time. Just above that, you have branch, or sometimes it's called decision outcome coverage, where you take each branch off of a if statement, for example, or maybe perhaps even a go-to. Not every branch has to be part of a decision construct, but you're testing all your branches, and that's just simply either, once again, testing your independent decisions or your anytime you're just transferring control to another area of the code. Then above that, you have condition coverage. These are where many times you'll find your do whiles and do untils. Then if you're testing conditions in conjunction with other conditions, that's multi-condition coverage. If you've achieved multi-condition coverage, you have automatically achieved condition, branch, and statement coverage. And then finally, at the highest level, we have path coverage. And this takes you down through every possible way to get through the code that you can travel. And kind of like with multi-condition, if you've achieved path, you've also achieved multi-condition, condition, branch, and statement coverage. Now I'm going to show you a few examples of these. So like with statement coverage, you could test this little routine with just simply covering every statement, and it would be meaningful. You would at least be assured that you've gone through the code every way you can go through it for this particular routine. So it's just things like setting the error code to 0, set account status to N, compute first value equals days in month time monthly rate. There's no ifs, no decisions, no do whiles, no loops or anything like that. It's just simply basic statements that do things, but there's no branching involved at all in this. Now, branch coverage, once again, is just testing either the decision branches that you take or any other kind of logical branch, like going to some area, other area in the code. So in this case, if the customer code is A, we're going to set the discount rate to 05. Else we're going to set the customer discount rate to 0. And by testing each of those sides of the if statement, we've completely covered that if statement with branch coverage. Now with condition coverage, this is where we're going to do, let's say, a do while or do until, something like that. We're going to use a perform command here to perform rate ID routine through rate ID exit until the ID code equals the customer's rate code. So we're going to stay in here until this condition becomes true, then we go out. And that would completely cover that code if you're just using condition coverage. Now here's where it starts to get interesting, where we have multi-condition coverage. So if the state is Oklahoma and the customer code is B, then we set customer discount rate to 04, else set customer discount rate to 0. Now if you recall from the first example that I gave you that kind of had a similar if statement like this, I kept all that as one node. This time, just for the purposes of showing multi-condition coverage, since A is a condition and B is a condition, I'm breaking them out into separate nodes in my control flow chart. So if A is true and B is true, then we go down to C. We set the customer discount rate to 0.04. However, if A is true and B is false, then we don't do the setting of the code. We go to D and then we go down to exit. And then if A is false, if it's not Oklahoma, then automatically we don't care about B. We then are setting our discount rate to 0 there too. And I forgot to draw my line across there to exit because C is going to fall through to the end. So multi-condition coverage, you'll see that we've covered all the statements, we've covered all the branching and everything in doing that one. And finally, we're going to do path coverage one more time here, just as an example. Now, what I'm about to show you could be tested with statement and a path coverage only. Once again, remember that one builds on the other. So this is a little bit more complex than the first one that we saw, but it's kind of the same idea. In fact, it's definitely the same idea. So we're going to read the customer file, that's the title or the label, and then we're going to open the customer file. We're going to read customer recs until end of file. If the customer status equals current, then we go down to node B, where if customer order stat equals pending, then we go down to node C, perform check order status through check order status end. Now, if the order status is not pending with B, then we perform prep order through prep order end. And then if A is not current, then we just simply fall down here to the end of everything, to the else next sentence. So the way this looks on a structure chart or a control flow chart, however you want to call it there, we have various paths that you're going to see build out here. You have the A true to B true path, and then you get down to C. If C is true, then you immediately go down to E. So that would be path 1. If you stay in that loop there where C is false, that becomes path 2. And then we have the situation or the possibility there where B is true and we have C going through false, coming out true. That's the third path. Then we have A going down to B. That's true. Just falling through. B is false. We go through D. D is true. We go down to E. And then that's our fourth path. Then we have the path where A is false. That would be path 5. And then we want to pick up this one too, where if D goes into that loop, once it goes out of the loop, or it stays in the loop while it's false and then goes out when it's true. That becomes the 6th path there in that example. So there you have it. Those are the levels that you can achieve in white box testing. Once again, just be aware that white box testing alone needs to be counterbalanced with functional testing, just to make sure that the implementation has been done correctly. Now, if you want more information, I've got my course on unit testing, like I mentioned. You can get that information and register at mysoftwaretesting.com. But really, a great book on this. This is an old book. You can buy it at the used booksellers online, like ABE Books or Alibris or some of those places. But Boris Beiser's Software Testing Techniques, second edition. It's a very technical read, but it does go into detail about some of the things we've discussed here, plus many, many more technical testing kind of topics. I highly recommend it. It was the first edition of this book that got me into software testing. So I have a warm place in my heart for this book. So if you have any questions or if you need any more resources, just let me know. You can reach me through my other website, riceconsulting.com. Actually, that connects into mysoftwaretesting.com. You can email me at webrequest@riceconsulting.com. And I invite you to check out my YouTube channel. Of course, you're already there if you're watching this video, but this is the URL for my YouTube channel. I've written 3 books, co-wrote 2 of those with Bill Perry, Surviving the Top 10 Challenges of Software Testing and Testing Dirty Systems, and my most recent book, The Wit and Wisdom of Software Testing, where I unpack about 35 or so of my Randyisms that I have uttered over the years in some of my testing courses. But I want to thank you for watching this video. I appreciate it, and I look forward to maybe having you contact me if you have any questions, or I hope you check out some of my other videos. I've got a weekly podcast out there too that we discuss all things testing. It's called the Value of Testing podcast. So anyway, once again, thanks for being here. Thanks for watching.